Bonjour, guys. In today's video, we're gonna talk about the physics quantum. As we all know, energy is conserved in the physics world. The total energy in a closed system before a physical change is kept constant after the change. And in today's, there are another quantum is also keep constant. The conservative, and his name is momentum. And this is my partner Steven. He's in charge of theory part.
Hola, and in today's experiment we have two main characters, and they are these two cars. And from the beginning I'm gonna use this electronic balance to weigh these two cars and see what is what. Let's see. And the first weight is 159 grams. The second car weighs 161 grams. So as we know, there is a basic equation about the momentum is momentum equals to the mass times by the velocity, and assume there is a P1 and 0.159 times by the 0.02 divided by the T1. As we know, this figure illustrates the length of the path, which is the light gate, and divided by the first time which the velocity and the first through the light gate, and minus 0.161 times 0.02 divided by the T2. And that is basic logic about the P1. And if the final P1 is almost equal to the negative P2, which is P2 is also equals to this equation, but the time taken is different because it's time taken when the car moves back to the light gate. And if this equation is right, we can illustrate there is a conservation of momentum in today's experiment. And now I'm gonna invite my colleague Justin to introduce today's equipment about this experiment.
Okay, thanks to Steven and Justin. The funny thing is, look at these two power strips. They connect the power supply and support the power for this air pump. And these air pumps provide the air for this shaft to let the two cars to be suspended on this shaft. It's no friction anymore. And then these are the two light gates, which will record the times when the two cars go through them. And this sensor, which could give the results on the screen. Okay, now let's do the experiment.
And before the experiment, we need to figure out there is no resultant force disrupting this experiment. So the time taken the two cars pass through the light gate should be quite similar. And let's see on the track.
Well, let's get started.
Here are the results. As we can see, the total momentum before the collision and the total momentum after the collision is roughly the same. The difference is within 0.02. And the reason for this arrows could be the air resistance and energy transfer. Some kinetic energy could be lost into the internal energy. But hence, anyway, we can prove that the conservation of momentum is true in elastic collision.
That's all.
Keep following us.
See you next time.